Hello everyone, welcome back to Human Resource Machine. Let's continue with level 36 Alphabetizer. Please be advised this optional hallway is for advanced employees only. Yes, indeed. Goodbye. Click. Incoming message. You will receive 2 words. One is a decoy, a false lead, a red herring. The other is part of an important message. The inbox contains exactly 2 words. Determine which word comes first if you were to order them alphabetically and send only that word to the outbox. Okay. 2 words. So first is unfit, second one is something else. So we need to compare them letter by letter. So first letter against the first letter of the second word, which means we should read everything out and put them on the floor first so we can compare. And I see they give me 0 and 10, so let's use those 2 numbers as the starting index. So let me make a copy of these first. This is my index 1, and then copy from this. Copy 2, and this will be my index 2. Alright, now I'm going to start reading. So inbox, copy that to the address by index 1. I want to keep doing that until, no, not negative, until it's 0. So when the inbox hits at 0, that means it's the end of the string and we can stop. And now we do the same thing again, but for the second word. So jump if 0, copy 2. Now this is going to be the address by index 2. Jump back to here. Okay, now we have both words copied together. Copy it onto the floor. So next up, we need to compare them. So we need to start again at the first letter. Oh boy, okay. So we need to reset our index again. So this is copy from this one, copy this to index 1. This resets that index back to 0. And then do the same thing with this. U. Okay. We need a way to tell when the word ends. So maybe I will copy a 0 to the floor as well. That way we know when the word ends, because if, let's say we have 2 words that are exactly the same, and we compare them letter by letter, by the time we reach the end, we haven't gotten a result yet, and we're gonna get in trouble. So yeah, I'm gonna have the words end. So now we have reset the indexes. Now I want to get the letter at index 1. I'm going to compare that against the letter at index 2. And this is when we do the actual comparison. So if it's negative, it means index 2 is bigger, and we want which word comes first if you were to order them alphabetically. So let me make a comment here. This is 2 is bigger than 1, which means word 1 comes alphabetically. So I probably want to copy from the starting index of word 1. Okay, and eventually I want to output that to the outbox. So let me make a note here that I want to output starting with the index that I have in my hands. Let's work on the other cases though first. jump if negative. Now we have another case. If it's not negative, it could be 0. If it's 0 though, that means the letters match and we need to compare the next letter. So this is 2 equals 1. Alright, so we already got, we have index 1, index 2. This is where we read the letters. So we actually want to just bump up each of these indexes and then get back to comparing the letter. Now we have the index pointing to the next letter, do the same comparison. Okay. Now if it's neither negative nor 0, that means it's positive, which means 2 is less than 1, which means we have our alphabet order determined and we should output word number 2. So we want to copy from the index, starting index of our word 2 and jump over to our output section. So this is where we do all the comparison. We compared all the letters, determined the alphabetization, and now it's time to make our output. We have our starting index in our hands at this point. Let's copy that to here. We want to copy from the letter pointed to by our index, send that to the out box, except if that letter is 0, then we are done with the whole process and we can go all the way back to the beginning. If it's not 0, if the string has not ended, then we send it to the out box and then we want to bump up the index to get our next letter, and then we get our next letter, keep getting new letters, and send everything to the out box. Let's see if that works. Oh, no. I am not incrementing. Okay, copy to index 1, and I want to bump up index 1. Maybe only do that if it's not 0, because otherwise it's kind of pointless. Bump up index 2. Okay, because when it was running, it was all copying all the letters to the same slot, and it was not bumping. Okay, do I need to bump anything from here? I did bump that. So that should be okay. The solution works, but it fails on other possible inputs. Okay, I did not expect that. But for some reason it was still running after it finished outputting everything. It should just stop. So let's see what it was doing. Oh, okay. No, never mind. It just came back to the beginning to reset the indexes for the next inbox, even though it didn't have anything in the inbox. Okay, so let's see what inputs it doesn't work with. Oh, I'm thinking, if the words are not the same length. Okay, let's run this and see what error we get. Yeah, these two words are not the same length. And so we would be comparing 0 against E. Okay, and it says I can't subtract with mixed operands. Okay, well, that's kind of annoying. So, yeah, again, normally if this was a real computer, then you can subtract 0 with a letter, because 0 is just 0 and the letter is a positive number of some kind. These are all numbers in a real computer, but here they don't let you do that. So let's see what we can do. Copy from index 1. we'd have to test if each one is 0. Let's see, copy from here we get our indexes. And here is where we get the values, but let me test each one. So let's copy from the address of index 2, and I'm going to test if that value is 0. If index 2 is 0, then index 2 has already, word number 2 has already ended, and if it has ended, then it cannot be later in the alphabetical order. So I'm going to jump right here, because in that case, word 2 has already ended, so it has to be earlier in alphabetical order. And here we copy from index 1. This is the letter from our word 1. I'm going to do the same thing, except if this one is 0, then 1 has to come before 2 in alphabetical order, and so it is this case over here. Alright, let's try that. Oh, now it's giving me the same words. It's being sneaky. I do believe we have this case handled correctly, though. Yay! Size is great. We can increase speed a little bit. Okay, I think I have an idea on how to make this much faster, but it's going to be pretty hairy. So what we've been doing before is copy both words onto the floor and then comparing them letter by letter. But once we have the first word on the floor, we don't actually need to copy the second word. For the second word, we can just go letter by letter from the inbox and compare it against the first word. Yeah. That'll probably save a lot of time because we don't need to copy all this, so we can get rid of all this stuff, and we don't need to keep track of 2 indexes, so this one we don't even need. But eventually when we need to output the words, it's going to get a little hairy because we'd probably taken some letters from word 2 already, and we need to kind of stitch the word back together because we have not saved the entire second word. So let's get to it. We don't need to set this index anymore. We just need index 1. This part is still good. This copies the first word onto the floor. Next, we reset index 1. This is also the index. This is just an index of which letter we're working on right now. So let's see what we can do. This one was trying to get the second letter. So let's not do that. Instead, we're going to get a letter from inbox. And I will save this to slot 10. Actually, why am I even doing that? That's not necessary. Let's just save that to slot 10 directly. And if that is 0, we're still in the case where 2 is less than 1, so we'll figure out how to output this after. But otherwise, we check the first word and see if that's a 0. If that's a 0, we still get into this case, and we'll figure out how to output that properly later. We subtract the 2, we still do the comparisons. Okay, so here we have all the cases, and now we need to figure out how to output correctly, because if 2 is less than 1, especially in this case, we don't have the word written out anywhere, so we need to output this correctly. So let me make another, just to say between here and here, this is where my output logic needs to be. So let's get that. Over here, we have our current, so index 1 is going to have some value. If it's 2, for example, that means we have already compared 0 and 1, and we know letters 0 and 1 are equal between the two words. Now 2 is the one that we're currently comparing, and we know this one is not equal. So what we're going to do is copy from 0 again, copy to this one, and this will be our output index. So the output index starts from 0, and between 0 and our index, we know both words have the same letters, and so we can take these letters off of the floor from the first word, and because they're the same letters as our second word. Let's get the letter addressed by our out index, put that in our out box, and then we need to bump up our out index and jump back to getting the next letter. Now there are a few cases. So there's the case where out index is equal to our index already, which means we are at the last letter where we're comparing. That's where we need to stop. So we have our out index. Let's compare that against our index. And if this is 0, this jump should go over here because we have our out index, and now we're comparing against index. If this is 0, then we are done with this loop. So far we have copied the letters from the start of the word until the letter that we're comparing. After that, we need to take slot 10. This is where we stored our current letter from word 2. So now we have a current letter in the outbox. And the final phase is the rest of the letters that we haven't read from the inbox yet. So take our inbox, unless this is 0. Unless this is 0, in which case we should just stop. Yeah. Just stop and start over. Alright, now we know this is a real letter. We get our inbox. Again, if we read a 0 from inbox, then we should stop. Otherwise, send that directly to the outbox and repeat. I really hope this is gonna work. But yeah. So basically the output goes in 3 phases. The first phase are the letters that are equal between the two words. So we take index 1, we keep repeating it. Oh, it's possible that these two words... No, we're good. Keep repeating for each of the letters that are the same. And these letters are not going to be 0, because if the letter was 0, it would have jumped. It would not have bumped up the index, right? Yeah, it only bumps up the index when the words are the same. So our index only contains the letters that are the same and not 0. Yeah. So when we copy from here, we know these letters cannot be 0. We get everything, get the next letter. The next letter could possibly be 0, in which case we jump. And then we get everything from the inbox as long as the inbox doesn't end. Okay. I'll probably forget something, but that's okay. Do I need this jump? No. This jump doesn't do anything anymore. Alright. Next case is if they are equal. If they are equal, we continue to bump up the index and go to the next letter. The next letter, we still get a letter from the inbox and do our regular comparison. This is good. Where does this come from? This is if negative, so if the words are the same, if the words have been alphabetized. This one is if index 1 ran out of letters. Okay. Now if 2 is greater than 1, we're still outputting the full word number 1. So this should be much easier. Copy from 23, that's 0. We should reset the index. Copy, yeah, I believe this should be correct because there's this one, we're just outputting the first word. And the first word is still on the floor as it was before, so no changes there. Let's try it. Empty value, you can't subtract with an empty tile on the floor. Okay, so what am I doing? Out index. Oh, no, I should not subtract out index. That's not correct. Subtract 10. This is current letter. Let me do this. Current letter of word 2. Yeah, so when I get the inbox, I'm copying it to this slot which contains the current letter, and then here I'm taking the letter from word 1 and also subtracting the current letter. It should not be out index. And this one, yeah, this one is correct. I'm trying to get the current letter. Okay, let's try it again. Fails on their possible inputs. It's probably the case where we need to output the second word. So let's run this and see what goes wrong. Bad tile address, okay. Where did I try to get copy from 0? Why am I copying from 0? This is totally not right. What am I trying to output here? I'm trying to output the... yeah, out index. There should be out index. I don't know why this was 0 before, but... yeah, we did it. Speed, speed. Very nice. Excellent. Next level, 37, is Scavenger Chain. Cough, cough. Yes, it's getting a little drafty up here. Facilities management has been notified, but we still have work to do. Each pair on the floor contains data and the address of another one of the pairs. Okay, so E would be the data, and then this is an address. This points to 13, so the next one is S, and points to 3, the next one is C. Oh, so basically escape. A scrambled chain. Each thing in the inbox is an address of one of the pairs. Outbox the data for that pair, and also the data in all following pairs in the chain. The chain ends when you reach a negative address. Repeat until the inbox is empty. Okay, basically this is an exercise to make sure you really understand the difference between values and addresses. Here, 13 is the value, but it's at address 1. And then you go to address 13, you get the value at address 13. And then you go to address 14, you get the value and use that as the next address, and so on. So yeah, this is the thing that took me years to understand. But hopefully I got it right in my head now, and this will be easy for me. So get the inbox. That's going to give me a number. In order to address it indirectly, I'm going to have to copy it to a slot, so I'm going to use 17 for that. let me get the value from the address in slot 17. So this is gonna be the first letters. That's gonna give me E. I'll send that to the outbox, and then I'm gonna want to bump up 17 to get the next address. I'm gonna want to copy the value from the address in slot 17 again. That's gonna give me the next address, and let's copy that to 17. In fact, if I just do this, I don't need to have another copy to 17 instruction here. So 17 is going to be updated with the new address, and it's going to continue in this loop until I reach a negative address. So hopefully they'll never give me a negative address in the inbox, and so copy from the address of 17, I can test if it's negative over here, and if it's negative, then go back to the beginning and get the next inbox. Yes, very good. Yeah, that was basically a knowledge test. The algorithm is not very complicated, but it is difficult to get the concept of addresses in your head. Level 38 is Digit Exploder. Our users have been rating some of our hardware products with 1 star. With user reviews citing draws too much power and overheats, numbers are too complicated for test subjects, occasionally removes alarming volume of skin from human users. So management has come up with a solution to make the numbers smaller and easier to understand. Grab each number from the inbox and send its digits to the outbox. For example, 123 becomes 1, 2, and 3. Alright. Yeah, we have 110 on the floor. So this is basically a division exercise. So 225, you want to basically divide it by 100, see how many you have. That's a 2, so you send that to the outbox, and then you take the remainder of that, which is 25, divide it by 10, and so on. So let's get our number, and I'm pretty sure I would need to store it somewhere, so let's use slot 0 for that. First, we would want to start subtracting 0. And we also want to copy some zeros and copy this to at least these 2 slots. This one's going to track the number of hundreds we have. This one's going to track the number of tens we have. We got the initial setup, we got our number. So let's subtract 100. Now, if the result is negative, that means we don't have any more hundreds. So we would want to add back 100 to restore our previous restore our number to a positive value. Copy this to... No, we don't need to copy just yet. We want to start subtracting tens. Let me make a note here. This is start 10. We're starting to subtract tens from this point on. Alright, let's work on the top though. I subtracted 100. If it's not negative, then that means we took 100 off of the number. So let's bump up this, because we have counted 1 times 100 in our number. And let's copy the result to 0 so that we can retrieve that again. Yeah, and I think we can just jump up to here, except we also want copy from 0. All right, we got our number. For our number, we're going to subtract 100. If it's negative, we're done. If it's not negative, we put the number back, bump the number of hundreds, and go back to the beginning. Okay. If we're negative, though, we're not quite done because, well, we do want to add 11 back, or, okay, I guess we can just keep the count over here. We'll use that to output later. We don't have to output immediately. So let's work on the tens. Tens is going to be basically the same thing. We're going to copy from 0 again, subtract the 10 this time. We have jump if negative, have copy to 0, we have bump plus. This time we're bumping up this slot, which counts the number of tens we have. We're jumping up to before we copy from. And over here, this is our negative case. We want to add back our 10. And so now we have the count of hundreds, a count of tens. And over here, when we're done with this add 10, the value that we have remaining in our hands is the units digit. That would be the 5. We'd have 5 remaining down here. So let's, since we're copying from the value again, we don't need to worry about destroying the value. So let's outbox. I want to get the number of hundreds and outbox that, but only if it's not 0. Because for a number like 88, I'm pretty sure they don't want 088, they just want 88. And let's see, add. Yeah, this is going to be a similar thing. So we want to copy this to 0. Copy from 7 this time. And then jump if 0. With an outbox. This outputs the number of tens, and only if it's not 0. And finally, all we need to do is copy from 0 and outbox the final digit. And the final digit can be 0. If it's 0, we'll just output 0. That is fine. Jump back to the beginning where we set up all the values. This is, hopefully that's good. Oh, it fell on some inputs, okay. Let's see what it fails on. Maybe the 9? Let's run it and see where it fails. Oh, sneaky, it has a 0 in the middle. Okay, so for the tens digit, I do need to output 0 if the hundreds digit was not 0. Okay. Well, let's do, yeah, let's copy from the hundreds digit. If this is 0, if this is 0, we'd want to test if the tens digit is also 0, and if it is also 0, then we skip. But if the hundreds digit is not 0, then we'd want to copy from, we want to get the digit and tens digit and put it in the outbox. Okay. Okay, we need to optimize things. Size needs to be reduced and speed needs to be almost doubled. Alright, here's something easy we can do. Remember when we subtract the number, if it's negative, then we come back and add 11 and put it back into the slot? Well, these are totally not necessary because over here we already have the number. This is still positive from the slot. When we subtract 11, if it's negative, we never update the slot. We don't write the negative number into the slot. And so by the time we jump down here, slot 0 is still going to contain the last positive number that we've worked with. So we don't need to add stuff back and we don't need to store stuff back. Same thing over here, we don't need to add and store. So that already reduces our program by 4 instructions. And that should be enough to meet the size challenge. Yeah, we got the size. Now speed, we still need to work on. Alright, this episode is already getting pretty long, and I didn't see any easy ways to help us dramatically increase our speed. And so I'll just end it here for today. I will come back to this next time and hopefully find a solution that will beat the speed challenge. That's it for today. Thanks for watching. See you next time.